Florida is facing a geological crisis that is speeding up, and Miami's very foundation is beginning to fail. This has nothing to do with hurricanes or storm surge. There is no wall of wind or rain crashing in. Instead, the land itself is disappearing, as if the coastline were unplugged and drained away. Imagine going to sleep with a wide sandy beach outside your window and waking up to find it simply gone. Not eroded over years. Gone overnight. A massive void forms beneath the water, and the sand starts sliding inward, pulled down as if by a giant invisible drain. Tourists flee beachfront hotels in their sleepwear. Emergency sirens cut through the morning air. Entire stretches of shoreline are suddenly closed because authorities cannot determine which sections of land might collapse next. What truly alarms scientists, however, is what follows. Thick black tar begins washing onto beaches, but testing quickly confirms it is not from an oil spill. This material is ancient, organic matter trapped underground for thousands of years, now seeping out through fractures that should never have opened. Then something even more unsettling happens. Florida starts experiencing earthquakes. So what is actually breaking beneath Miami? Are these isolated sinkholes, or is there a vast, hidden cave system below the surface capable of turning an entire coastline into a zone of collapse? On December 18th at 6:47 a.m. Eastern Standard Time, a Coast Guard patrol vessel cruises across calm waters off Deerfield Beach when its depth finder displays readings that defy logic. The screen shows 40 feet of depth, even though official nautical charts list the area at just 12. Lieutenant Commander James Walsh radios the coordinates again, assuming a malfunction. The system checks out. Minutes later, aerial surveillance confirms something no one expected. A massive sinkhole, nearly 300 feet wide, has opened on the ocean floor overnight while Florida slept. At 7:23 a.m., another collapse tears open near Pompano Beach. This one is larger, measuring nearly 450 feet across. Along the shoreline, tourists recording the sunrise capture the moment the ground beneath them begins to slide. The beach does not wash away with waves. It sinks downward. Alarms echo across Broward County. Hotel guests rush outside clutching children, phones, and chargers, uncertain whether the land beneath their feet will still exist the next day. Lifeguard towers lean at strange angles as the seabed pulls sand outward, like a drain opening beneath a postcard-perfect shoreline. By 8:15 a.m., a third sinkhole ruptures the seafloor near Boca Raton. The Florida Department of Environmental Protection moves immediately into full emergency response. Director Amanda Torres coordinates with emergency offices across 15 counties as reports arrive faster than crews can be deployed. Surveillance aircraft sweep the coast, scanning underwater terrain with sonar. The first images freeze command centers in silence. These collapses are not isolated events. They are linked. A massive underground system is failing in real time. At 9 a.m., officials close 47 miles of coastline, stretching from Port Everglades to Palm Beach. The Coast Guard establishes exclusion zones extending 2 miles offshore. Law enforcement blocks beach access as confused crowds demand answers. The numbers escalate quickly. 12,000 tourists displaced. 8 major resorts evacuated. Beneath calm blue water, new voids continue forming. This is not erosion. It is structural collapse. As morning progresses, restrictions expand rapidly. Yellow caution tape flutters in places where beach umbrellas stood only hours earlier. Patrol boats create a moving barricade offshore. Swimming, surfing, and boating are banned near the affected areas. Onlookers gather behind police lines, staring at water that appears completely normal. But sonar imagery tells a different story. The ocean floor is no longer intact. It is breaking apart. Before noon, 12,000 tourists are forced out of beachfront hotels. 8 major resorts shut their doors. Families roll suitcases along sidewalks, searching for transportation inland. Emergency shelters open in Fort Lauderdale and West Palm Beach, filling faster than staff can register arrivals. By lunchtime, Several shelters reach standing room capacity. At 11:42 a.m., updated aerial imaging confirms officials' worst fears. 23 separate underwater sinkholes scar the seafloor across 15 square miles. Some have formed recently. Others are expanding by the hour. Dr. Marcus Reynolds of the U.S. Geological Survey studies the data with visible concern. He describes it as an unprecedented collapse event, something never before documented in Florida's geological record. Early damage estimates already exceed $2.3 billion, and the total continues to climb. Engineers warn that beaches are only the beginning. The same limestone platform beneath the seafloor extends under highways, residential neighborhoods, and high-rise buildings. If the collapsed network spreads, structures once thought stable may begin shifting. Officials attempt to reassure the public, but privately, one question dominates every briefing. How far does the underground failure extend? Florida rests atop a vast slab of limestone. From above, it feels solid and dependable. In reality, limestone is porous, resembling a rock sponge. And that sponge is dissolving from within. Rainwater absorbs carbon dioxide from the atmosphere, forming a weak acid. Normally, this process erodes limestone slowly over centuries. But conditions have changed. Rising seas push saltwater farther inland, accelerating chemical reactions. Processes that once took generations are now unfolding within months. Dr. Sarah Chun of the U.S. Geological Survey explains it plainly. The rock is being eaten alive, and it is happening faster than models ever predicted. Emergency sonar mapping reveals what lies beneath the coast. A massive network of cavern stretches from Miami north to Jupiter. Some chambers rise 200 feet tall. Others run for miles. The images resemble Swiss cheese rather than solid ground. Researchers at the University of Florida construct three-dimensional models of the coastline's foundation. The results are deeply troubling. Entire communities sit above hollow chambers that were never documented before collapses expose them. Multiple forces are converging at once. Sea levels rise incrementally each year, increasing pressure on already weakened rock. Saltwater intrusion weakens limestone up to 40% faster than historical records indicate. Temperature fluctuations cause expansion and contraction, further fracturing the stone. One geologist calls it a perfect storm for geological failure. The statistics reveal the severity. Florida once averaged 2 or 3 sinkholes per year statewide. Now, collapse rates approach 12 per week within the affected zone. Monitoring stations detect underwater acoustic anomalies, the sound of rock cracking in real time. The ground beneath Paradise is no longer stable. It is breaking. At 7:15 that same morning, lifeguard Marcus Johnson steps onto Deerfield Beach and stops cold. The sand is coated in thick black tar, not scattered patches, but a continuous sticky band stretching as far as he can see. Cleanup crews soon collect over 2,400 pounds of the material across a 12-mile stretch of coast. Initial fears point to an oil spill, but within 6 hours, petroleum is ruled out. This substance is far older. Dr. Angela Martinez, a marine geologist at the University of Miami, examines the samples under high-powered microscopes. Carbon dating reveals organic material trapped inside limestone between 15,000 and 50,000 years old. Ice Age remnants are washing onto modern beaches. Maps show the tar deposits align closely with offshore collapse zones. Where the seafloor sinks, ancient layers are exposed. Seals that held for millennia have fractured. Swimming bans expand along 31 miles of coastline. Wildlife impacts escalate quickly. Dozens of sea turtles ingest tar. Dolphins show respiratory distress. Rescue centers are overwhelmed. Methane readings spike near collapse areas, suggesting gases released from deep fractures. Scientists begin calling the tar a geological warning system. If material buried for tens of thousands of years is reaching the surface, fractures must extend hundreds of feet into bedrock. The ocean is not just pulling sand away. It is ripping open layers of earth never meant to re-emerge. In Pompano Beach, Maria Martinez stands outside her family restaurant staring at cracks that did not exist the day before. The building survived hurricanes and floods, but overnight, thin fractures spider across the walls. A building inspector arrives with grim news. The structure is compromised. Evacuation is immediate. For 18 years, the restaurant held 3 generations of memories. Valued at $2.8 million, it is insured against storms and fire, but not ground collapse. Maria packs photos and clothes, while her 8-year-old daughter asks when they can return. There is no answer. Damage spreads beyond individual buildings. Highway A1A near Deerfield Beach develops stress fractures. Engineers swear were not there 72 hours earlier. Crews measure 6 inches of subsidence across a 3-mile stretch. The road closes abruptly, diverting 45,000 daily commuters. Emergency repair estimates reach $89 million, but no one can guarantee stability. Just before midnight, Ocean View Towers, a 22-story high-rise housing 340 residents, reports foundation movement. At 11:47 p.m., a mandatory evacuation order is issued. Residents have 2 hours to pack essentials. Elevators shut down. Elderly tenants descend dark stairwells assisted by firefighters. Shelters overflow. Additional facilities open, but beds run out quickly. Alongside physical damage, a mental health crisis emerges. Children wake from nightmares of the ground disappearing. Anxiety prescriptions surge across coastal counties. Fear shifts from storms to the land itself. On December 20th at 2:34 a.m., a magnitude 2.8 earthquake strikes 15 miles offshore near West Palm Beach. Seismographs light up. Scientists stare in disbelief. Florida does not have earthquakes. The state lies far from tectonic boundaries. Yet within 1 month, 17 detectable tremors occur. Experts explained these are not traditional quakes. The signals suggest collapsing rock, pressure shifts, and water rushing into voids. Temporary seismometers line 100 miles of coastline. Data reveals constant microtremors advancing northward at nearly 3 miles per day. Worst-case simulations suggest events reaching magnitude 4 or 5 are possible. Florida launches earthquake preparedness campaigns for the first time in history. The limestone does not stop at Florida's border. Similar formations stretch north along the Atlantic coastal plain. Within days, neighboring states begin emergency surveys. Economic consequences ripple outward. Insurance markets react. Property values plunge. Coastal sales freeze. Federal relief requests escalate. 1 week later, 47 miles of coastline remain closed. Tens of thousands remain displaced. Damage estimates exceed $25 billion. Unlike hurricanes, this disaster does not pass. There is no clear end. Beneath Miami's skyline, limestone once thought eternal reveals its fragility. Scientists continue monitoring fractures that remain open. The chemistry dissolving the rock does not pause. Communities show resilience, but no amount of human strength can seal fractured bedrock. Confidence in the ground itself erodes. When that happens, everything built upon it begins to shake. The deeper fear is not just about beaches or buildings. It is about permanence. The belief that land does not vanish overnight. That belief no longer feels certain. Florida's geological nightmare has accelerated beyond expectations. Miami's foundation is already failing. And as the Atlantic coastline stretches north atop similar rock, one question remains beneath the calm surface of a sea. If the Earth itself can give way without warning, how stable is the future we believe we are standing on?